Welcome to our panel on revolutionizing manufacturing. I want to thank the Business Roundtable for pulling together such an important discussion today. I also want to say hello to our viewers who are streaming online at cnbc.com and over the internet, and hello to our studio audience, and of course, welcome to our guests who are here today. I have with me Blake Moret. He is the President and Chief Executive Officer of Rockwell Automation. It is the world's largest company focused on industrial automation and information. We also have Jim Keane. He is the President and Chief Executive Officer of Steelcase Inc., the global leader in office furniture industry. And we also have Mike Molnar, who is the founding director of the Office of Advanced Manufacturing at the National Institute of Standards and Technology. Whew. He is also responsible for NIST advanced manufacturing programs, and he's the liaison between industry and academia. And I want to start by talking about the framework for today's discussion. We have all known and discussed about the renaissance that we're seeing in manufacturing right now. And that renaissance is not just about the number of jobs that we're seeing in manufacturing, which have grown by 1.5 million over the past few years, but it's also about the shift that we're seeing in manufacturing itself. Technologies like AI, we're seeing more automation. So today we want to discuss the applications for some of these technologies, the challenges that companies are facing as they try to make this transformation, and also what it means for the workforce that we have today and the workforce that we're going to need in the future. So I'd like to start with Jim, because you use automation and big data both within your company, and you also help other companies design their workspaces to take full advantage of these new technologies. So when we talk about smart manufacturing, what do we mean? How do you explain it to your customers?
Yeah, so first of all, I think we've used technology for a long time in the world of manufacturing. What's really changing is now we're using it beyond the traditional uses. So traditionally, we might use it to measure inputs and measure outputs in a manufacturing process, maybe the flow of materials across the plant floor. But now we can use new technologies, sensor technologies, combined with learning algorithms to do things we were never able to do before. So one example of this, so we make wood desks, wood office furniture in Grand Rapids, Michigan. And one of the big challenges we have is that every day we receive thousands of pieces of veneer. These are slices, thin slices of trees. And we have to combine those to create furniture, and it has to look like the furniture is all made from the same color, the same pattern. And that's always been something we've managed to pull off through people trying to make the best choices they could. Today we have a system we've co-developed with an outside partner that uses a visioning system that can look at every single piece of veneer as it comes in, and then uses a scoring algorithm that can identify the color, the texture, and several other attributes of this product. And what's really cool about this is that allows us to tag each piece of veneer. So when it comes time to make your desk, we can make sure that all the veneer there will actually match as closely as we possibly can make it match. And every desk we make, every day, every month, every year, that learning algorithm gets smarter. It learns from its own mistakes, and it learns to be better than any of us could ever be. And then finally, it replaces a job that was a very tedious job. Can you imagine having to be that person who had to look at nothing but veneer all day long?
You go cross-eyed.
You would, and now that person can do other things that really more fully unlock the full potential of humans. So there's an example of how new technologies are creating what we consider to be smart manufacturing.
So using the technology not only to manufacture the product, but also to improve productivity and to improve efficiency. Blake, how far along are companies in making this shift? Are all the companies as progressive and innovative as Jim's, or what are you hearing when you talk to your customers?
We're really seeing that inflection point take place right now. So for years we've seen companies be more efficient gradually at manufacturing by basically automating repetitive physical processes. That's the basic control. But now we're taking the data, that's a byproduct of those manufacturing processes, and turning it into useful information that unlocks a whole new level of productivity. So it helps these manufacturers be more efficient, get their products to market faster, to be able to increase the yield in their operational processes. It also, and this is an interesting phenomenon, it also helps level the playing field between large and small companies, because with a lot of the cloud-based resources, with the flexibility in manufacturing processes today, scale is not as important as innovation.
Mike, what are the ways that federal policy can help encourage more companies to make this leap? What are you seeing?
Well, that's a very interesting question because, and actually much of the other panels going on at this event is talking about this valley of death that we as in the United States lead in this discovery and innovation. And yet if we don't capture this innovation, we scale it up, we de-risk it, and we make things, we're losing out on jobs, we're losing out on economic impact. But the other thing that we've learned is that manufacturing in general, and advanced manufacturing in particular, is really part of the innovation ecosystem. So much of the federal programs, you're seeing this trend toward having industry-led public-private partnerships rather than federally driven programs by themselves. That pull from industry is helpful to address this valley of death that we hear about. And one of the ways that we do that is these Manufacturing USA Institutes, of which relatively new program, 14 institutes. Blake serves on the BioFab Institute, but 2 of those institutes are on digital manufacturing and smart manufacturing. So why is this important? Well, it really is a revolution afoot in this digital manufacturing. But the other interesting thing about the United States is that of the 250,000 manufacturing companies, 99% of them are small and mediums, and they don't know how to take these new technologies and integrate them into their products and services. So that's what the federal government is doing, is creating these collaboration spaces to help bridge that valley of death.
And Blake, that sort of ties into the point you made about leveling the playing field now. There was just a meeting today at the White House on industries of the future, and one of the focuses of that meeting was on advanced manufacturing, and the administration saying that this is an area that they want the U.S. to dominate in. Is the U.S. dominating in this? Are we leading the way, or are we behind the pack here?
I don't think we can say that we're dominating. I think the U.S. remains a leader in terms of the innovation that is going to drive leadership in overall advanced manufacturing. As I said before, scale is not going to be as important as innovation. And so the ability not only to come up with the new technologies, but also the business models, the ways to combine that innovation with the expertise and to drive it in ways that these companies can monetize, either in terms of saving money or making more money by launching new lines of business. I think the U.S. has every opportunity to be the world leader in that.
So is that the challenge then, trying to show companies exactly how to apply these technologies? I mean, it's a lot of gee whiz, right? But how do you actually apply it to your business and make it work for you?
Yeah, so I'll give you one example. So we have operations science and a large number of people who know a lot about how to run efficient factories using lean manufacturing and other principles that we've learned from other companies around the world. Something we did recently when we realized the importance of information technology is we asked our CIO, our Chief Information Officer, to take a new job leading global operations. So in the past, the head of global operations would have come up through the factories. But now to have career paths that integrate the expertise of IT people along with the expertise of operations people, you're able to monetize more completely. So I'll give you an example of that. So if we want to make a chair like the one we're sitting in, we have chairs that take about 4 minutes to manufacture.
This is a steel case chair.
It is a steel case chair.
It is a steel case chair, all right.
You look very comfortable in it.
It is. Sees my body just nicely.
So if it takes 4 minutes to manufacture, that seems pretty efficient, but these days we have to be better still. So our teams in the factory are working to try to get to 2 minutes. And we've already done all the things we can think of on lean and so on, automation of each individual process. Now it becomes more complex. Now we have to think about variations in flow that might occur because of a change in a fabric or a change in configuration, or just the fact that we want to add some people to the line when we're busy or remove people when we're slow. The way we're able to do that now is by taking sensors that come from the IT world, integrating these sensors throughout the line, and then using data and algorithms to understand long-term patterns. how the ebbs and flows of those lines might vary based on the kind of product we're making. So in the past, we might have said, we can't predict when that traffic jam could happen on the line that could cost us some efficiency, but now we actually could. Like if the algorithm can look into the schedule and says, you know what, at 1:30 today, you're gonna have a problem, now our operations leaders can use that IT advantage to avoid the traffic jam in the first place, which monetizes the technology. But that crossing over of IT and OT was the key to that.
So a lot of the companies that are probably thinking about whether or not to make this investment are not as large as you guys are. How should they think about deploying resources then? And by that I mean two parts. One is, how much is this all going to cost? Sounds great to be able to, analyze and crunch big data, but how are they going to find the money to do that? And is this a large capital investment? And then also, when you think about sort of the structure of your organization, your point about breaking down some of those silos is really interesting.
Yeah, the first place to start, whether you're a small company or a big company, is the objective of how it's going to save you money or it's going to unlock a new line of business. So
spend money to save money.
Yeah, you absolutely have to understand what you're going in, what problem it is that you're trying to solve, and then that'll help gauge how much you're able to spend on that. We talk a lot about pilots where you can very clearly define what it is that you're trying to solve, where you think you can save the money. Every time we do this with a manufacturer, they find other uses of the technology, and there are ways to find even more savings in other places. But you have to start with a basic idea of what problem or handful of problems you're trying to solve. Then you need to assemble the team. And what Jim talked about, we see is absolutely crucial in terms of blending the worlds of IT, which have all sorts of technology that are applicable, with the operational know-how, the understanding of the application. And we see that both in the part of suppliers as well as the users needing to be able to make organizational changes to most effectively utilize these new technologies.
Mike, when you talk to industry groups, when you talk to businesses, what do they come to you and say they need help with? Is there a regulation, is there legislation that they point to say, if we had this, we could unlock a lot more potential?
Oh, what a good question. Well, let me approach it as manufacturing in general, is very sensitive to taxes, trades, and regulation. And the administration has prioritized manufacturing, U.S. manufacturing, and has been pushing on all three of those fronts. In addition to that, advanced manufacturing with these very high return on investment, transformational technologies that could create whole new industries. That's also sensitive to technology transfer and educational workforce skills. It really surprised people that even during the Great Recession, the number one thing that we were hearing from manufacturers is we can't find the workers with the right skills. So we have to do this on taxes, trade, regulation, yes, but also on these high impact new technologies, the technology transfer. We are the envy of the world. The federal government invests $150 billion a year in research and development. And as we heard on the other panels, the director of NSF just a few minutes ago, there's this valley of death. So how do we ensure, this is why under the President's management agenda, this return on investment for ensuring that the investments in basic science and research are translated to benefit the private sector. So to your point, what are we doing about that? Well, one is this, I mentioned earlier, this public-private partnership, working together. I cited two of the institutes. Another institute is on advanced composites. It's not inventing carbon fiber composites, but it's how do you work together on something that is so big that a single company, a single university, a single government agency can't do by themselves, but together through this collaboration in a neutral commuting ground they can do. So this Composites Institute, their goal is reduce the cost of composites by 50%, increase the recyclability by 70%, and reduce the energy impact by up to 90%. And so the example here is a consortium just engineered and made, and this is led by small companies, new composite fiber, the wing spars for the windmills. so for wind power. And that's how you get these things across. It's scaling up and de-risking them so that the small companies can create these new innovation ecosystems.
Is the challenge to ensuring that this technology and the benefits of these new innovations stay in America, is the challenge to that a workforce issue, or are there broader supply chain issues that make it difficult for companies to make sure that the fruits of their innovation are then reinvested in American jobs?
Yeah. Well, certainly workforce is a huge piece of it, and you'll hear that theme over and over today, how central that is to fuel innovation. And it involves the principles of lifelong learning, so we have to have a student population who's comfortable first with STEM, and then to be able to move into more directed technologies. But very importantly, that doesn't necessarily mean having to have a 4-year degree. We're training returning service people typically with high school education for technician level jobs where when they have the basic occupational specialization from the armed forces, we then put them through a 12-week hands-on program, and they're ready to take good, high-paying technician jobs in industry today. And that workforce is a vital piece of it. I think the other piece to ensure that we keep it here is, of course, the intellectual property protections that we cherish in America as well.
And I'm very bullish on American manufacturing. We have factories all over the world, but we also have 2 factories in Michigan, factories in Oklahoma, in Texas, in California, and those factories are very vibrant and very competitive. I agree with Blake about the workforce. So, and in fact, the Business Roundtable and the business community is doing a lot right now to try to work with government and to work with education to build the kinds of systems that can help us activate more of America's workers. That starts with apprenticeship programs and internship programs, liberalizing and broadening those programs to match what other countries have done very successfully. We can see those models and we can replicate those models. It also includes businesses taking a second look at how we're defining the job requirements of some of these technical jobs, so that not every job automatically requires a bachelor degree. Some might require an associate's degree. Some might require high school with some additional training. And also thinking about how government agencies direct the money they use to help disadvantaged people access education. Again, it doesn't have to just be four-year schools. What about all the other ways that people can learn? How can we make some of those resources available? If we can do that, we have enormous potential. This country has huge advantages, and American manufacturing can benefit from a more highly skilled workforce, the technology that companies like Rockwell are developing, and American innovation.
I want to come back around to workforce development in a minute, but I also want to talk about tariffs. We have had a discussion so far about ways to improve American competitiveness, but a lot of what we hear from business leaders, and certainly the fear of investors, is that the current tariffs, the threat of additional tariffs, would make American business less competitive. Have you guys seen the impact of the tariffs, whether it's on steel and aluminum, on Chinese products? Has that run through your supply chain at all? Are you feeling those costs?
Let me start by saying the uncertainty around tariffs is not helping things. I think that's clear. The two pieces that affect us would be the input cost and then any changes in our consumer buying behavior. In terms of input costs, by having a flexible supply chain, a flexible manufacturing footprint, and selected price increases, we think that we're able to mitigate the result of any additional cost. And we don't use a lot of iron and steel and aluminum. We're more of an intellectual capital company. We have not seen yet the tariffs directly affect the buying behavior of our customers as they seek to automate. But again, the uncertainty doesn't help.
And with a name like Steelcase, you can imagine it had an effect on us. So only a very small part of the steel we use in the U.S. comes from outside the U.S. and it's specialty steel. And in fact, we got an exemption from the tariffs because it was seen by the government. Yeah, we had a legitimate reason to say that the tariffs don't apply to that particular kind of steel. And virtually everything else we buy that we manufacture in North America is U.S. sourced steel. However, what's happened is when the steel tariffs came into force, it caused U.S. domestic steel prices to rise such that really everybody's paying the tariff, whether you buy your steel in the U.S. or not. Now, the disadvantage to that, and this is the problem with tariffs, is that some of the implications are easily anticipated, but not always thought through. It actually creates an advantage for our competitors who manufacture, say, steel file cabinets somewhere else in the world, because they can buy steel at the global price of steel, import those products tariff-free. It's the steel itself that's being tariffed, not the products made from steel. So we're a resilient company. We've been through things like this before. We found ways to work through this between price increases, changes in our supply chain, and so on. But as Blake said, tariffs distract us from our energy applied to more important things, like how do we continue to innovate.
Another issue you guys raised is the issue of privacy. I guess there are two sort of fronts to that, one being ensuring that innovations here in America are protected, intellectual property is protected, and also as we talk about a more connected production line, a more connected workspace, that that privacy is embedded within that environment as well. Can you guys talk to how you approach this issue and what type of framework do we need to see both from the private sector and the public sector in order to ensure that business privacy is protected?
So the other part of our business is helping people work more effectively by providing office furniture and a lot of other products, including technology products. So we're helping clients these days understand how their workplace is utilized. As the workforce has become more mobile, people aren't always sitting at the same desk throughout the day. You have different conference rooms that are used in different ways. And for facility managers and real estate managers, they want to understand the ebbs and flows of use in the work environment just as they do in the factory. Now that can create a challenge, and what we want to be very careful about is what we're doing here is measuring the utilization of the space and trying not to capture information that's personally identifiable information that could be used against an individual employee. So companies, I think, who begin doing technology-based solutions have to, from the start, be mindful of these issues and to take steps to make sure that we're respecting the rights of individuals.
Mike, how does this apply to your job?
This is very important, but actually NIST plays a special role as the federal lead for cybersecurity, and so the NIST cybersecurity framework is the gold standard of having a secure organization.
And what is that framework? What does it say?
So the framework is exactly what should an organization do and how it should do it. And as you know, the devil's in the details. These leaders of major corporations, they have a tight lid on cybersecurity. We're going to say that, right? But
hopefully there's not a data breach tomorrow.
They use that framework.
And they use the framework. And as I said earlier, but the lion's share, their tier 1, tier 2, tier 3 supply base, those are small and medium-sized companies. And those are the ones that are most at risk. So among many things that we do, one is the Digital Manufacturing Design Innovation Institute. We've started up a cybersecurity institute for what research and development do we need in this. But NIST also sponsors the Manufacturing Extension Partnership Program with centers in every state. And their role is to educate small and medium-sized companies, manufacturers, what do they need to do, how did they do it, and how can they connect these things. So we think that it's an important part because especially when you're a very small manufacturer, you don't know what you don't know. And the first step is understanding this is a big deal, and the greatest risk to these tier 1 companies are the supply base, and that's why we're very focused in that space.
Rockwell has an extra couple of things to worry about in addition to protecting our own intellectual property and the personal information of our employees, and we do use, of course, the NIST framework. We're also, as a supplier of technology, needing to make sure that critical infrastructure is as resilient as possible. And so we talk about a defense in depth strategy that hardens the end devices, these devices that often have communication ports on them, and it's basic things like making sure that you can't put in a unauthorized thumb drive and things like that. it's the communications network, it's the software, it's the firewalls, and really importantly, it's the human element of this as well. It's the access control and making sure that we're guarding against the insider risk. I think the final point is that you're never done with this. It's a constantly changing attack surface. The bad guys are finding new ways to get in. And so the best you can do is to be the hardest possible target in terms of your own internal defenses, as well as what you're providing through your technology to other companies.
If I may add one thing, you might find it surprising that the business community would be interested in having more regulation, more legislation. But in fact, in this area of privacy, a number of us believe that it makes sense for us to work with the government to create federal legislation to protect consumer data, and to be something that the business community can do in concert with government to protect consumers and give people a promise that they can count on, regardless of whose product they're dealing with.
And I think the BRT today released some of the principles for that privacy framework,
exactly,
including transparency, being able to control your own data, et cetera. I want to come back to the workforce quickly and ask about the shrinking labor pool that we're seeing. You guys have talked already about, even during the depths of the recession, there being a skills gap and it being difficult to fill jobs. Now that we're seeing the labor force tighten so much, how does that translate into the types of people you guys might be taking a look at? How does that translate into how you're able to fill open positions? What are you seeing and how is it impacting you?
Well, I think we have to be able to take advantage of the broadest possible workforce, and so that certainly speaks in some part to looking at a diverse candidate pool, and that's diversity in all its forms in terms of educational background and other aspects of diversity, so that you can consider the broadest possible base of people who have the capability to perform these jobs. I think the other point that we made earlier is that we have to get away from some traditional views of all the important jobs needing advanced educational degrees. And I mentioned before what we're doing with technician level skills. These veterans and other people who move into these technician type jobs recognize just how important they are to the success of the overall company that they're working for. And so I think there's a perception issue as well to make sure that they understand this is important work. And with their background and with a desire to succeed, they can fulfill very important roles in these companies with great opportunities to succeed. And then the other half of the idea of lifelong learning is that even if they got into that work with a basic level of education, there need to be more on-ramps future in their careers to be able to get the additional training so that they can pursue other branches of a career path.
Do you think, though, that we will ever get back to a labor force in which there are 20 million manufacturing jobs in America? Or are we permanently seeing a smaller manufacturing base in this country?
I think, well, the notion that manufacturing is like agriculture, that everything will be automated and automation will displace jobs, that's really a misnomer. The companies
the robots aren't coming for us, is what you're saying.
No, the companies that actually employ productivity enhancement, automation and such, are the ones that have above average growth, and that growth increases their labor pool. The key point is that the manufacturing workforce of the future will be very different than my father and his father. These are high-tech, high-touch jobs, and they're also very high-paying. And so although it's low unemployment right now, there's still a huge skills gap. And what the federal government doesn't want to do is limit U.S. manufacturing because they can't find the right workers. And this skills gap is only increasing. So I really appreciate our prior comments about, it's not that we need more PhDs, but actually what's a greater need is skilled trades. And how do we get these things with apprenticeships and internships and thinking differently? I just want to make one other point, that the things that we're making today are not the way that things were made before, of somebody drafts something and you pass it along. it's a systems problem. And this is where the U.S. can really excel, because we are a nation of innovators. We are a nation of team builders. And so we need to have teach collaboration like this.
And that is a great segue into our final question here, which is if you guys can engage in a very quick future cast, if you will, and say, where do you see manufacturing going in this country? Where are we going to be 10 years from now? Well, we have made that shift.
We're going to see the simplification of adding this new technology into manufacturing, so that even as we have these technologies that are bringing about great productivity in certain areas, the fact is that we're going to continue to have to deal with the workforce that may not be immediately ready to deal with the complexity that exists today. And so simplification over the next 10 years, I think, is going to sort out the winners and losers in our space to make it easier and less risky to apply that technology.
So Jim, do you think the workforce in 10 years will be ready for that simpler, smart technology?
I think so, because I think if we invest in technology skills, that's part of the problem. I mean, I think what's happening now is we're going to use technology to do things that technology should have been doing all along, allowing people to do things that people are really good at. What I'm excited about is new kinds of jobs. So let people practice empathy, for example, which help us understand human problems, understand how to create new ideas, negotiate with each other, persuade each other. Everything we're trying to create in society around diversity and inclusion can link back to also creating a different kind of employment expectation where people can actually be more human as the technology does things that we've asked people to do for 50 years.
Great. Mike, your final thought.
Yes, I brought a show and tell because I think I am so bullish about U.S. manufacturing and our future, and it's because we're doing things differently. And one of the problems that I see is that we talk about STEM as STEM is good for you, you know, learn this stuff. And it sounds like erase STEM and put broccoli. Broccoli is good for you. I think your friend Dean Kamen with First Robotics. My younger son is on a First Robotics team. And this team looks like America. There are more girls on his team than boys. And they're designing and building robots. And
it's millennials who built that chip that you're holding there,
so
right?
They're learning how to program. That's great. What I'm showing here is from one of our institutes. This is a future. This is flexible hybrid electronics. And this is an Arduino. What the first teams are programming, this is a real Arduino. And this was designed by a high school student after 3 days of instruction. And then after 2 more days, she produced it. So first tier, learn how to program, great. Second tier is learn how to design. Third tier is if you can make it, you can create whole new industries.
Mike, that means the future is literally in your hands. With that, thank you so much to our panelists. Really appreciate you being here today. Wonderful discussion. Thank you all.